We have a speaker today all the way from the Autonomous University of Barcelona who's come to do research at UC Merced, Gara Villalba, and she works with students and sets students on their path and careers and lots of other things too. So I'm so excited. She studied chemical engineering, and I'll let her do the rest of the talking. So let's give her a big hand. Oh, not only that, but she's an incredible rock climber and mountaineer.
Good morning. Thanks so much for inviting me and taking the time to come out here. As Karen said, I am a chemical engineer, and I am part of the faculty of the Department of Chemical Engineering in the Autonomous University of Barcelona. So I've put up some pictures so you see what Catalunya looks like. That's where Barcelona is in. And now I'm here at UC Merced for a couple of years. During this time, I'm doing research, and I'm also supervising some students in some of their master thesis and such. So one of the reasons I was really excited about coming here today is because I know a lot of you are right at that time, finishing college and trying to decide what it is you're going to do next year. So up to now, you've had pretty structured way of moving forward year after year, and now all of a sudden you have to make all these decisions. When I went through that process, and that was definitely many years ago now, it seems like, unfortunately at that time, everybody around me, including college counselors, basically told me, you have to get an engineering degree. If you don't get an engineering degree, you can forget about having a job, you can forget about being a happy person, having a happy marriage, having kids, retiring someday. You can forget about anything in this life unless you have an engineering degree. That was the 90s, technology. And I'm really happy to see that I really think we've kind of moved away from that a little bit. I think that we've really come to realize that technology is very important, but just as important as the technology is an understanding of the Earth systems that support it, that gives us all the materials and energy that we need to have those technologies. It is also important to understand the impact of those technologies on our Earth, right? So there are the natural sciences. There's a huge link between natural sciences and engineering in that respect. Also, what we do in terms of technology also has to be socially acceptable. It has to be something that, really improves quality of life and our environment. And then also, it has to be economically feasible, right? So you see how really, especially when we look at solutions or technologies that will make us have a more sustainable society, we really have to work from a multidisciplinary framework in order to have that happen. Basically, I think the take-home message here is that whatever discipline you decide to study, I think it's very important that you realize how that complements or is complemented by other disciplines. And I think that's great news because what that means is that whatever you decide to study is actually going to have a lot more fields of application than you can even imagine or envision right now. So for example, I have a colleague of mine, I'm working with him, and he has an undergrad, his undergrad was computer science. So when I say he had an undergrad in computer science, what is the typical job of a computer science degree that you envision? Programming, right? This kid is in a cubicle programming for Microsoft all day long, right? So, well, it turns out that he is using his computer science knowledge to program an atmospheric model to try to determine how gases move in the atmosphere. And so he's had to complement his computer science with chemistry to find out how the chemistry of those gases is working in the air. He's had to complement and work with people in the field of physics because he really needs to know the transport, right, in terms of radiation, in terms of wind gradients, in terms of all these other parameters. So you see how, he really has to pull from all these disciplines. But for his job, this base, this knowledge of computer science was very important. So I think that it's really important that when you think about different things you can study, that you see what those people are doing right now with those jobs and how all the different applications they can have, and not just go with your stereotype idea of what that job is, right? Is I'm going to present a project that is multidisciplinary, and so you'll see how I work with other people from different disciplines to do something that I think is really exciting. I hope you'll enjoy it as well. When I talk about climate change, I mean that the impact of our activities is causing climate change in a negative way. In other words, called anthropogenic activity, right? So because of all the activity that we do that can really be translated to the use of energy, it's resulting in a greenhouse effect, which is basically a concentration of gases we have in the atmosphere. Right, we're able to receive some of the light and some of it stays within the earth, and that's why we have the climate that we have. But because of all the activity that we do and a lot of energy consumption that we do and other activities, we're increasing the concentration of some of these gases in that greenhouse effect, and so we're actually retaining a lot more of the heat than we would like, than what is actually sustainable. It turns out that most of these greenhouse gas emissions, that's what we call them, these greenhouse gas emissions that we're adding to this greenhouse effect, are mostly coming from cities. And it's important because cities actually contribute about 70% of GDP that we use to say how healthy is the economy of a country, right? So the bigger the GDP, the more you're producing, the better you are. They have 50% of the global population, and by 2050, we're expecting that they will have 70%. And that will be resulting in about 90% of the greenhouse gas emissions worldwide will be attributable to cities. And so this is going to have some key problems in terms of climate change. We're going to see warming. We're also going to have limitations in water supply. There's going to be more problems in terms of pollution, extreme weather conditions. This will also affect food supply, etc. So these are some key problems that we try to find solutions for in cities. As a matter of fact, we're saying cities are having these greenhouse gas emissions due to their energy consumption. Can you guys tell me some of the things that are being done here in Mariposa or Merced or even larger cities that are solutions trying to reduce these greenhouse gas emissions?
Lots of people are moving to solar power.
Solar power, so cleaner energies, right? We're not using fossil fuels, which the fossil fuel combustion is one of the biggest greenhouse gas emitters. But there's a lot of other things too. Everything needs energy, right? Let's think about even the recycling programs, right? The fact that we have recycling programs and we are trying to give our waste a second life and optimize resources that way, that means we'll have to extract less of those, right? So that will also mean less energy is needed. That will also mean less greenhouse gas emissions, right? So you see that it is all sort of interrelated because of this energy, right? Energy is very important in materials. What we have found is that especially buildings are a big energy consumer. I would say it's probably about 35 or 40% of the energy consumption in cities after transportation is the biggest, is heating and electricity in buildings, right? So as you were saying over here in the back, more energy efficient. We're looking for more ways to make these buildings, right, more efficient. I put this picture up here because when we talk about some of the things that you've told me, more using renewable energies or being more energy efficient, we're really focusing on the use of the car, for example, or in my case, the use of the building, right? We're being more energy efficient with our heaters, so we use less energy, for example, less propane, right? So we're really focusing on the use phase, but there are more opportunities for reducing impact if we take into consideration the whole life cycle of that product. Life cycle approach, and this is very important. And this is something I would love for you guys to learn from my talk today, is this life cycle approach in which we're not just interested in what's going on when we use the product or the technology, but we're also interested in all the extraction of all the materials and all the energy that was required to make that product exist, right? So the extraction of materials, the producing or manufacturing, right? And then we have the use, and then also the end of life. So it's this whole life cycle approach that we need to use when we evaluate things, so that we are not maybe being really good about increasing efficiency here at the cost of maybe having to get some materials that require a lot of energy to extract, for example. Now I was going to talk about this project, and this is not what I'm doing at UC Merced, but since I just kind of started at UC Merced, and I wanted to show you maybe some results and be able to talk about it a little bit more, I'm going to talk about this project that I'm doing with a couple of students that are still there in Barcelona. And this is a rooftop greenhouse which we're doing to optimize food production in buildings, right? So we're saying, okay, cities, we want to make them more sustainable. We're gonna focus on buildings, and we're going to try to reduce the carbon footprint of the buildings. Greenhouse gas emissions, the one that's produced the most are carbon dioxide, so carbon. So when we talk about the carbon footprint, means in its whole life cycle, how many carbon dioxide emissions has is this building producing, right? During its lifetime or per year, then you define the time. So we are trying to reduce this carbon footprint by actually producing food on top of this building with a greenhouse on top. So when we had this building constructed, we already, which is for one of the research labs there, we had the top floor ready for this lab that we were going to set up. So it would be the top floor, and it actually has 4 greenhouses all facing different orientations. So here the aims were to demonstrate the feasibility of producing food. Secondly, besides the fact that we wanted it to make a business sense, we also wanted to determine the potential of exchanging flows between the greenhouse and the rest of the building in order to reduce those greenhouse gas emissions, in order to reduce that dependency on energy and water. How can we make this building be more self-sufficient, in other words? We are working with designers, architects, engineers, agronomists, so you see that it's very multidisciplinary. We have people helping us with the crops that are from agriculture. We have the architects for making sure that the building was constructed exactly how we needed it for being able to have all the airflows going in the right direction, and the orientation for the greenhouse. Just some pictures of getting that lab set up. So here's the other thing, right? So it's at the top. We cannot just fill up the building with soil, so we have soil for these plants up there. So we're using the carbon dioxide, right? We're all breathing out carbon dioxide constantly. So the moment I get to a certain concentration, like 400 parts per million, I'm going to send all that residual air up to my greenhouse to optimize the growth of my crops up there. So I'm capturing the CO2, right? I'm reducing the greenhouse gas emissions. I'm reducing the carbon footprint. All right, so this is where my chemical engineering knowledge comes in, of trying to understand the mechanisms of producing those greenhouse gas emissions, right? So because, and I didn't mention this before, yes, the CO2 emissions from the building are going up to the greenhouse gas, and they're being captured by photosynthesis. But what other gases do you think might be a problem here because they're greenhouse gases? Methane? No, we don't have any anaerobic digestion or any anaerobic bacteria up there that might be producing methane. We're not composting, for example. That's a good one, though. One that living here, especially in the valley and all the agriculture that is happening, we should know, is nitrous oxide emissions, okay, N2O. They have 300 times the potential of CO2 as a greenhouse gas. So it's as if we had 300 molecules of CO2. That's how high the impact is in affecting our greenhouse in the atmosphere. So it's important to know that we are producing those all the time we are using fertilizers, because we have reactions of nitrification and denitrification that you might have studied in chemistry. I'm not sure. I won't get into that now. I don't want to. That's not the topic of my talk. But basically, we have different mechanisms for producing these N2O, nitrous oxide emissions, right? So here the idea is, okay, we're capturing CO2, but we're emitting N2O, right? We're emitting these nitrous oxide emissions. So what's the balance here? And so basically that's, I'm not going to go into that. That's the experimental. I'm not going to have time for that. So basically that would be the balance, right? We're capturing with photosynthesis. We're producing, and you'll notice here the E is for equivalent. So I have changed those nitrous oxide emissions to what their equivalent would be in CO2 through denitrification. And so I can calculate the net contribution of that greenhouse on my rooftop that's producing those tomatoes. But what do I compare that to? Well, I would have to compare that to those tomatoes being grown thousands of miles away and having to be transported to be eaten in that city, right? And that is a gazillion times number of greenhouse gas emissions than this, right? So these are the types of analysis that we do, and how we compare and how we can come up with solutions that are economically feasible, socially acceptable, and have a technology behind for a more sustainable city. The benefits are also all around, right? So we have environmental benefits, because we're decreasing energy consumption, we're decreasing water demand, and as I sort of hinted at before, we're decreasing the requirements in transporting that food from sources way outside and far from the city to the city. So we can say that we're actually optimizing the metabolism of the building or of the city because we're optimizing all those flows. Societal benefit, accessibility to healthier food products because you have the direct control over its production. Community development, traceability of food, you know where it's coming from. And benefits from a financial perspective, decrease in food costs, local economies. Lastly, like I mentioned before, I coordinate a master's program in environmental studies. In the past few years, the focus of the master's program has been in cities and sustainability. And here I work with Aalborg University, which is in Denmark, University of Aveiro, which is in Portugal, and Hamburg University, TUHH, which is in Germany. And we have, so this is a little bit later. It's not undergrad, it's a master's program. But we get students from all sorts of disciplines who have an interest in that topic. And I just wanted to share with you some of the things that they've been doing. These students have had undergrads in environmental engineering, like some of them civil engineering, a lot of them even chemical engineering like myself, or even economics, biology. So here is Helene from Denmark. She did mobility and her project in Bangkok. So we have different partnerships with different universities worldwide. And so she was there for about 4 months, and her work there was to use GIS, which are geographical information systems, to try to investigate, determine the land use changes and their impact in a number of community forests. So she was there using these tools, and she's an engineer. We have Sophia, who's from Turkey. She went to the Earth Institute in Columbia University in New York City, with whom we also have a partnership. And there she looked at the adaptation of the electricity sector to heat waves. So heat wave is one of those impacts that cities are going to be facing, are already facing, due to climate change and a rise in temperature. And it's mostly affecting older people and children. Lydia, who's from Colombia, South America, she went to Beijing Normal University in China, and over there she studied different assessment or analysis that are available to try to determine the environmental impact of cities, and especially with the overdevelopment in China and the population growth. There in China, they're doing a lot of studies in that area. So as you can imagine, here the kids are not only learning through these projects and that experience, but also the culture. And I remember this student, for example, especially the culture shock was really great for her.
From Colombia.
Yeah, from Colombia. Well, she was in Europe for 1.5 years before she went over to China. but you know, just even different ways of the professor talking to students, how you can approach professors. It's just very different, and it's important and very enriching to learn to work in different environments. We have this girl from Vietnam. She is now teaching environment and analytical chemistry in Vietnam, where she's from. And she, you know, especially from the value that she got from such interdisciplinary learning was group work, project planning, implementation, presentation, language, problem solving in different contexts. Ahmed, who's from Egypt, and he also studied, he's an environmental engineer, is now working at a company called Environmental Systems Research Institute, and here he's using geographical information systems, just like Hélène, and this time to study electricity cables in cities, underground gas pipes, underground water tubes, heating systems, and streets networks to build what you might have heard are being called smart cities. So these are just, so you see what some of these students are doing now. And that is the end of my talk. Thank you.